So this is Unit 1, Module 2, Lesson 2, Variables and Input, and you should be working on the Fast Start activity. Once you get that completed, you're going to download the startup file. So pause the video and do that. When you open up the startup file in Dr. Java, which you could, if you haven't done that yet, open that so you have it in front of you, because I'm going to ask you to change a couple things. So when you have this, you'll notice there is something new, a new command that we haven't talked about. There's a new thing here, which we haven't talked about, and there's a new thing here, which we haven't talked about. We've talked about system.out.println, and we have our quotes with our string in it. Then we have this system.out.println, and we got something weird in here, which we haven't talked much about. And then we have another string. I'm going to throw some vocabulary words out at you today, which I'm going to briefly define, but we will continue to define as we move throughout the course in much greater detail. So don't be all concerned about getting the exact definition at this point, because these words have a lot behind them that I'm using. So let me explain some of the things that we're doing. The first new command here, scanner scan. Well, scanner is the thing that I'm building. I'm going to build a scanner, and what a scanner does is it looks for something, right? So the scanner in this case is looking for keyboard input. It's looking for something to be typed in by the user. Scan is the name I'm going to give it. I'm just going to call it scan. I could call it bunny rabbit if I wanted to, but we're going to call it scan. So don't think of the word scan as a particular name for a command. It's just a placeholder that represents the object, vocabulary word alert, object that I am constructing. Vocabulary word alert, constructing. So I'm going to construct a scanner object with the constructor, which happens to have the same name as the class. Another vocabulary alert. So we have class, constructor, and object. New vocabulary words. So class is like a blueprint that tells us how to build our object. The object is the actual thing. We give that thing a name. In this case, we're calling it scan. This is the information that is going to go into that object that helps us build it. So it goes into the constructor, which actually does the building. So this is the constructor. The constructor must always have the same name as the class. And I'm going to go into a lot more detail on that later, but I like to use the right vocabulary as we go through so we're not making anything up. It's always going to be the same words. The new operator tells Java that we're creating a new thing. We're instantiating, vocabulary word, a new thing. Creating it, instantiating it. So scan becomes an instance of the scanner class. So that was a ton of vocabulary I just threw at you. But that's the correct language for all of this. For this single line, there's like 8 vocabulary words that I just introduced in one single line of code. We're going to spend a lot of time talking about those 8 different words. Just not today, but we're going to keep working our way through those. So don't worry too much about not understanding all those words. That's fine. What the main piece of this command that you need to understand is we're creating something that's going to get user input. And our focus today really is going to be on that user input and something called a variable. Now, everybody has dealt with variables in math. Agreed? Nods heads. Yeah. Everybody's seen variables in math. Variables in computer science are similar, but have some major differences that we have to focus on. So you need to kind of do a mental shift. When we're talking about variables in computer science, they're not the same exact thing as variables in math. They're a little different in certain respects. So the first thing I have to do is I have to tell Java that I need a variable. And this variable is going to be of string type. So that's the class that the variable belongs to. So I'm telling Java, set up in memory some space for me that's going to hold a string. So Java does that. And then I tell Java, what I want you to do is put in that variable the result of the next line method from the scan object. So we have this object we created called scan, which scans the keyboard, and we have a method called next line. So think about it for a second. Tell me, to yourself, and tell me what you think it's actually going to do. So this is going to scan in a line of user input. But if you think back to what we said the other day, all Java input and output must be in a, remember the word? String. All Java output and input is done in strings. So when this scan line happens, it's going to bring in a string and store it in this string represented by the letter N, which is an awful variable name, and we'll talk more about naming variables later, but N is a horrible, horrible variable name, but it just gets us started. Then we do this system.out.println, and we're going to say print the string hello, a plus sign. Now the plus sign in this instance means to concat. Has nothing to do with pets. It means to put together. Concat means to put together. So it says, take the word hello, concat it with whatever is stored in that N, and then concat it again with nice to meet you. So the plus sign in this instance in Java means concat. The plus sign will not always mean concat. Sometimes it means addition. And we're going to have to figure out when does it mean concat and when does it mean addition. Some of the more obvious examples, if I'm adding two strings together, it's going to mean concat. But what if I'm adding a number to a string? What does it mean then? What if I add two numbers and then add a string? It gets a little questionable what Java actually does at that point. So we have to do some more investigation for that in a little bit. So when you run it, this is the box you get. It says, what is your name? And gives you this text box to type into. That is Java's way of looking for user input. And it will get the entire line that the user types in. When they press enter, Java will then take that information. So I type in Mr. McLaughlin. And it will print out, hello, Mr. McLaughlin, nice to meet you. It concats whatever I typed in and puts it in there. Much like, kind of like the Magpie did a little bit, right? It kind of bounced some answers back and forth to you. Things that you typed in, it threw back at you. Similar reactions, but that had more logic behind it. So the scanner stores that information in computer memory. So how does that work? Well, we get in memory this little box. And technically, what's inside that little box associated with the little letter N is a number. And that number is an address that's pointing to another box that's holding the information that is the string. That's called variable by reference. Again, a whole lot more conversation has to happen around that. So really what's happening is there's this information, Mr. McLaughlin, stored at a memory location that is identified in that little box. So there's a number, like an address. So you can kind of think of this as your street address is stored somewhere. Then if I go to that street address, I actually get the information. I get Mr. McLaughlin. So this is the street address. This is where it's stored. N, technically, is just storing the street address of the actual string. That's how all objects work in Java. Every object stores just the address of the object in memory. It does not store the actual information when it's an object. There is a way to store the actual information in a variable, but it's only very special types of information that we can store. We can't store objects because it's not big enough. It's only big enough to hold a memory location, a memory address, a number. So with that being said, you may have an idea of what we can store in variables that are not just addresses. So then the computer pulls this string literal, then does a concat with the plus sign, and then takes out of computer memory, goes looks at this address, which then looks at Mr. McLaughlin, and puts that with the word hello. And then finally it concats the last piece of it. So what is input? Input is pulling information into the computer. And for this to work, you have to have a spot in memory to hold the value. The information has to go somewhere. So whenever you're going to use user input, you have to store it in a variable. You don't have much else choice. It has to be stored somewhere. So we use this variable to do this. It's a box, really with an address. It's a spot in the computer's memory that the value can change while the programs run. What does an equal sign mean? Think about that for a second. In mathematics, the equal sign means you're comparing two things. If I say 3 plus 5 equals 8, I'm comparing 3 plus 5 to 8 and showing that they're the same. That's not what the equal sign means in computer science. Let me say that again really clearly. The equal sign in computer science does not mean a comparison. It means assign. Assign the value on the right-hand side of the equal sign to the memory location on the left. That's what the equal sign means in computer science. There is a comparison operator in computer science. It's an equals equals. You get two of them when you're comparing. So that's the first big mental shift with mathematics. Equals doesn't mean equals. It's not the same thing in computer science as it is in mathematics. A single equal sign means assign. So when we had our variable, we assigned it the result of the user input. If you think about it, that only makes sense because the user hadn't put anything in yet. We couldn't compare the variable, which was empty, to what the user put in, which was also unknown. That just doesn't make any sense. It's not logic. So we can't compare two things that have no value yet. So in computer science, the equal sign means assign. So x plus 1 equals 9. We do our algebra. We get x equals 8. That means x equals the value of 8 when we're comparing those two things. X and 8 are the same value in algebra. In computer science, that's not why it works. In computer science, you would say, ignore all the rest of this. If I say x and then this symbol and then 8, I'm assigning the value of 8 to x. It doesn't matter whether the math worked or not. I could assign it a 5. I could do all this lovely math and say x is assigned the value of 5. Because it's not the logical progression of algebra that you're looking at in computer science. This symbol means assign. So, couple rules for variable names. When you have a variable name, you can't use spaces in it, at least in Java. No numbers are allowed in the first spot, the first character of the variable name. So you can't do one test. And you cannot use reserved words like commands. You could not use print as a variable name. Because Java was like, wait, you want me to print? And then you want me to make it assigned? That doesn't make any sense. So you can't use words that are already used as variables. That's about it. There's also a couple naming conventions as a stylistic guide. In Java, often we start with a lowercase, and we use variables that make sense. So I might use a variable called first name to store somebody's first name. Using the variable n is not a good variable. But using the variable first name is a good variable because it tells me some information about what's being stored there. Also, because first name is 2 words, I need some way of denoting that it's 2 words. But I can't use spaces. So what we often do in Java and many other languages is we use a lowercase letter for the first letter and an uppercase letter for every word after. So we can visually see where the variable breaks, where the word breaks are inside the variable name. And visually, that makes a lot of sense. So we have this variable called first name, or n, if you really wanted a variable named n. But really all it's doing is it's pointing to a memory address. Stored in that variable is the memory address. It could be FA067. And that memory address points to some box in memory. Now we're going to talk more about this later, but that memory address could be assigned to more than one variable. Let me give you an example. Who in here has a nickname? So Catherine, would you like to share your nickname? Katie. So if I call you Catherine, though, you know who I'm talking about, right? If Drew calls you Katie, we know who you're talking about. 2 variable names, both referring to the same thing. If Katie changes her hair, then so did Catherine. Correct? If Katie wears different shoes, then so did Catherine. Because they're referring to the same person. So if Katie decides, I'm going to, I don't know, shave all my hair off, then Catherine has no choice but to go along with it. And if she starts arguing with herself, we all give her a lot more space than we're giving her now. So in memory, though, we have to declare what kind of space we're going to need. So yes, the n stores the memory location, but by saying it's going to be a string, Java knows how big of a box it's going to have to build that memory location is pointing to. So we have to tell Java that this is going to be a string, and it knows that I'm going to put strings in it, and it says use a big box for the string. Because you don't know how many letters that user is going to type in. Now, there is a limit, but it's a big number. That user could type in a lot of letters. So we have to leave enough space to handle the largest size string that somebody could type in. So, words, strings, or numbers. So, can we do numbers as strings? So it doesn't matter what I'm putting in the word hello, or if I'm putting in 765, anything between these 2 quotes gets treated as a string. Even though you might look at the number 765 and say, oh, that's a number. Java doesn't. It's between quotes. That makes it a string. If you store the number 765 in a variable that's declared as a string, it needs to be a string. You can't do math on it, at least not directly. So here's an example. One way of declaring string is by saying string in the variable name, and that declares the type. But Java created a way of doing this all in one shot. rather than having to do string n and then say n equals howdy, what we can do is say string n equals howdy. Or in this case, string word equals howdy. Word is just the variable name. So string is the type. Word is the variable name. Howdy is what's being assigned to string. So there's some memory location, EB64, and word is pointing to that memory location, and that's where howdy is stored. Now, strings are special objects because normally you need more than this declaration to create an object. Remember when we did scanner? I said scanner, and then I had to name the object, then I had to use the word new after the assignment, and then I had to call the constructor. I don't have to do any of that with a string because Java knows strings are so useful, they've shortened that. I don't need to say new string howdy. They put some shortcuts in so I don't have to type as much. That was very nice of them, but it makes teaching this a little confusing when you first start because people look at this and go, oh, that doesn't look like it's the same as every other object. But it is. Strings are treated the same as any other objects. They have methods. They're done by reference, which means you're pointing to a memory location that is pointing to some information in memory. So here is our example of the scanner class. It's the same type of thing as a string. It's an object. So we're creating a scan object. Using the constructor, it's taking system in as input. So that's our constructor. It's setting it up. Then we will want to use it. We say string n, which we already declared previously, and we're telling it to call the method scan.nextLine. Now we can also get an integer using the type int. And we say w is equal to scan.nextInt. And that gets an integer. That's not an object. Int w is not an object. It's called a primitive. There are certain numbers, characters, Boolean operators in Java that are not objects. So for this variable, the thing that is actually stored in the box is not a memory location. It's the actual information, the number. So if the person types in a 7, then the number 7 gets stored in the box. That is the variable w. If the person types in the word howdy for this line, what gets stored in the box is a memory location that then points to somewhere else in memory where the word howdy is stored. So these two things look very similar. You have a type and a variable name. You have a type and a variable name, but they're very different because of the type. Int as a type is called a primitive. String as a type is an object. Two different classifications. The scanner, you don't need to know how that works. Scan.nextLine, that's great. You kind of figured out what it does, but you don't need to know how it does that. You don't need to know how it gets that information from the computer. This idea is called abstraction in computer science, where you don't need to know how every single thing works in order to use it. It's the black box idea. You don't need to know how to rebuild your carburetor to drive your car. If you did, a lot of people wouldn't be driving. Or they'd learn how to rebuild their carburetors, which at a point they wouldn't be driving because their carburetors would be all over the place. So the scanner class is something we don't need to know, but it is specific to us, which means we brought it into the program. We imported that information. You might notice in your code there's a line, a couple lines at the top, and we'll talk more about this in the future, that import information. One of the things that it imports is the scanner class. So it's importing all that information that it needs to use in order to do those next lines. You don't need to know how it works, you just need to know how to use it. There'll be other objects like that in the future. So, you're going to use the template program. And you guys are going to try this. This is your homework tonight, so to speak. You're going to add a variable snack and ask the user what their favorite snack is. And then you're going to print whatever their snack was, sounds delicious. So you're adding to the template program a variable snack, ask the user what their favorite snack is, then print that their snack sounds delicious. So for example, if they said spinach, it should output spinach sounds delicious. Questions on that? Okay, so we're going to stop that, and you guys are going to work on that, and then look for the next video.